Okay. Integral of 2 minus t times, what was your number? I can use your number if you want.
Sure, it's going to be 0 to 5, and then it's going to be 5 minus t times the square root of t.
I like that, right? Okay. Alrighty, so we could just go ahead and multiply the root t in there. But let's show an extra step before we do that and rewrite that guy as t to the 1/2 dt. So if we integrate, multiply it out before we integrate, we will get 5 t to the 1/2 minus t times t to the 1/2 would be t to the 3/2. Let's add the fraction. Then separate the integrals and integrate these two separately. And that's pretty much it. So add 1 and divide by the result. So right now it looks ugly, but yeah, that's okay. We'll deal with the fractions. So 1 plus 1/2 is 3/2 divided. So this is divided by 3/2 here. This would be t to the 3/2 plus 1. So that would be 5/2. Sorry. When you divide by a fraction, you flip it and multiply. So that will be 10/3. That you guys see where the 10/3 came from for this coefficient? Let me show one extra step just in case. Do 5 times 2/3 times t to the 3/2 minus 2/5 t to the 5/2. That's where the 10/3 comes from. So I'll just evaluate and you're done. Okay, so that will be 10/3 times 5 to the 3/2 minus 2/5 5 to the 5/2 minus 0. Right, when you do the lower bound. So things as pretty as it's gonna get. We can combine these guys, I guess. I think because this power can be rewritten. Let's see here. These can be added together. See if it accepts this. If not, maybe we have to reduce it further. But I think that's good. Personally,
Okay, thank you.
I'm trying to see if I can make it prettier. There's going to be a, right, if we rewrite this one more step here, that's the same thing as saying square root 5 to the third. Square root 5 to the fifth, right? So that would be root 5 times root 5 is 5 times root 5. So this would be 10 over 3 times 5 root 5 minus root 5 times root 5 is 5 times root 5 is another 5. So that will be 25 root 5. Not a space though. Let's see. That'll be 10 times 5 is 50, right? So we'll put 50 over 3 on the next page. 50 root 5 over 3 minus 50 root 5 over 5 or 2. Oh, that should have been a 5 right here. Stupid thing in my way. Sorry about that. There was a little error here. It should be 5 from this 5. This should be 5 right there. Okay, so common denominator multiplied by 5. That'll give us 5 times 50. That's what, 250? 3 and 3 would be 150. So the answer would be 50. 250 minus 150 would be 100, right? Let me know if they took that other answer, because this may not be worth it. Well, you're welcome to go as far as you want, though. 5 goes into both. This would be the pretty answer. That's my alarm. Anyway, let's go over this one more time. Does this make sense? Like the first steps?
Yeah, it made sense. That was the right answer. Thank you. It worked out. I got stuck on just where you integrate it and just simplify it after that.
Oh, this step here?
Yeah.
Yeah, did this part make sense, the weird number stuff, or did it accept this one? Did it accept this?
It accepted the 20 root 5 over 3.
Oh, they wanted the pretty one.
Yeah. Yeah, I kept on doing it on my calculator, and it just gave me a decimal. Like, okay, I'm gonna have to really get in there.
Yeah, I didn't want to do that either, but oh well. But did you see how that worked though, or no? That's weird.
Yeah. It was just algebra after that, just very tedious.
Okay. As long as you see it, I'm happy then.
I appreciate it.
You have any other questions you want to do?
No, I'm good.
Okay. Anyone else struggling with anything on the homework or the review that you feel like didn't make sense? I will think about it for a second. Let me get my Coke out of the freezer. One sec. All right, I'm back. Sorry, my alarm went off and I didn't want them to explode in my freezer. Alrighty. Do you guys feel pretty confident on chapter 5? Is that what I'm hearing, or?
would like to go over problem 2 on test 4 review.
On the review?
Yes, sir.
Okay, let's do that. Number 2. Okay. Where's that damn thing? For test 4, right?
Yes, sir.
Okay. Here it is. All right. So number 2 from review. So find the antiderivative. Let's go ahead and put a integral symbol on it. It's x to the negative 5 plus 1 over 4 square root x. So 4 is a coefficient, it's not the index. We'll put a parentheses dx. So first thing we should do is separate it. So let's do it. The fourth can be pulled out as a constant. So did 2 steps there. Pull out the 1/4 outside and separated the two terms with their own integral. The first integral is just going to be, well, let's go ahead and wait before we do it. This guy is I'm going to rewrite this as an x to some power. So remember that this is x to the 1/2, right? Square roots. So then you make it go to the top and you get x to the negative 1/2, and then we start. So you got to do it kind of like a little setup. Make sure all the powers, make sure all the terms are not on denominators like this on the bottom. Bring them to the top. If you see any square roots, change them to fractional powers. We should always do that. Once we are ready, this will become negative 5 plus 1 over negative 5 plus 1 plus 1/4 times x to the negative 1/2 plus 1 over negative 1/2 plus 1. So that will give us, let's see. So that will give us x to the negative 4 over negative 4 plus 1/4 x to the 1/2 over 1/2. So at this point, we're pretty much done. We can bring that thing to the bottom, just make it like positive power, right? There's a 4 down there with this x4. This guy I need to flip and multiply. So that'll be 2 over 1 times 1/4, which is 2 times a 4th, which is a 1/2, right? Any questions on any of those steps? Does that make sense, or did you need me to show extra steps on anything?
I think I got it.
Yeah, just rule of thumb, make sure if the X is on the bottom, you bring it up before you start. And if it's a square root, change it to a power. You guys have any other questions for homework or review?
Professor, I have a question.
Yes.
Um, it's not about the test out. So I have a graphing calculator that I've been using.
Mhm.
And I was wondering, how would I put the trig function cosecant?
What are you trying to do? Like graph it or
Well, I was trying to go back. I'm going back to the earlier chapters on the questions like I just could not get. And I'm trying to do them. And like I'm in what am I in right now? Oh, I'm in 2.5. And it's the one where, do you remember where you have to look at the function? You have to like fill in the table of values for the function.
oh yeah, yeah. Those for limits,
Okay.
right?
Yeah, so this one it's cotangent and then it says pi x over 6. Well, when I'm trying to put that in my graphing calculator, I don't know what to put. Like at first I thought, well, maybe I'll put like cosine or tangent, but I'm not getting the right answer, so I don't know what to do.
You have to remember what the definition of cotan. So cotan is defined as 1 over tangent. So all you got to do is go in there and do 1 divided by 10 and then do your thing.
Oh my God. Okay. I was like so frustrated, literally about to throw my computer because I could not figure out what I was doing.
Yeah, there's no cotan button, so you have
Yeah, I
you have to
know.
use
And
that.
like, okay. I even looked on Google and I was like, I don't understand. Oh my God, thank you so much.
No, you're good. It's a good week to catch up on homework.
Yeah, I'm trying to go back on the ones that I know, like I was frustrated and I couldn't figure it out. And so I'm trying to do those again.
That's awesome. If you guys have no other questions, you're welcome to head out, or if you want to stick around and do problems, that's cool too. Either way, I'll be here. So let me know. Yeah, you can do fine, sure. number 5. Oh, here it is. Solve the initial value problem. dy dx equal to 1 over x cubed plus x. And then they tell us that x is greater than 0. And they give us an initial value of y of 1 equal to 2. Just remember that this is the same as saying 1 comma 2. They give us a point. Excuse me. Okay, so what you have to do is integrate both sides to solve for y. That's basically what you're doing. You're canceling the derivative in order to solve for y. Y being the original function. So this side just becomes y, these cancel. Then here we got to integrate this guy separately, this guy separately. So then this will be, rewrite this problem where it's at the bottom, so bring it to the top. And then we're ready to start integrating. So this will be x to the -3 plus 1 over -3 plus 1 plus x to the first plus 1 over 1 plus 1 plus c. So we need to solve for that c in just a moment. So y will become x to the -2 over -2 plus x squared over 2 plus c. Okay, so make this a little prettier, put the minus in front, put the half in front, whatever. So at this point, plug in 1 comma 2, the initial value, to solve for c. So plug it in for the y and plug it in for the x. So y is 2, x is 1, right? So then this becomes 2 equal to -½ plus a half plus c. These will cancel, meaning that c is equal to 2. So now our final answer would be this with the c. So this is what it means to solve the initial value problem, is you give them y 1/2 x to the -2 plus 1/2 x squared plus 2. You can go one step further and make this a positive power. But that's as pretty as it's gonna get, really. But either of these would be fine with me, you know. At that point, you've done most of the work anyway. Any questions on any of the steps? Is that okay?